Now that we know how to recognize acids and have a little idea of what acids are, let's go into naming these acids. As we said before, that acids will fall under three categories based upon the kind of or the name of the anion they would produce when dissolved in water. If you remember from a previous session that acids dissolve when dissolved in water, so HA, when it's dissolved in water, it ionizes in such a way that it produces H plus ions that are also known as protons, but not really the same kind of protons that are subatomic particles in the nucleus of an atom. These are just known called protons, even though it's an H plus ion, and anions. Now, the acids are divided into three categories for naming purposes based on the name of the anion. And that is why it is very important to know these, because we have to start working from that in order to name the acid. Acids can either be considered to be "-ide" acids if the name of the anion it produces name ends with an "-ide". Acids can either be "-ate" acids if they produce 8 anions, in other words, the name of the anion ends with an 8, or "-ite" acids if they produce an anion whose name ends with an "-ite". Once again, I cannot emphasize enough how important it is to know the name of these anions. Okay, so let's look at naming "-ide" acids. Those are the ones that when they are ionizing in water will produce protons and an anion whose name ends with an "-ide". The rules, the steps for naming these are, first step is we attach a prefix hydro to the name of the anion. We take the stem of the name of the anion and replace the "-ide" with "-ic", and then attach a separate word, acid. Let's take an example. Let's take an example of an acid HCl. It's a molecular compound, and also it has an H as the first listed element in the chemical formula, therefore it is an acid. Now, if you remember from previous session, if this dissolves in water, the molecule will break up in a chemical process to produce H plus ions and Cl minus. This ion is called chloride. In other words, once again, focus on the name of the anion. Since the name of the anion is ending with an IDE, the acid falls under this category. So we start with the name of the anion. We attach the prefix hydro to the name of the anion and then replace the "-ide" with "-ic", and then a separate word, acid. So Cl minus is chloride, but HCl is hydrochloric acid. Okay, let's give this a try. Name a few other acids using the same steps. Once again, we'll go very slowly for the first one, and then I'll let you guys do the others on your own. It's very important to know what would be the anion produced when the acid molecule dissociates. So, excuse me, not dissociates, my mistake, ionizes. When HCN ionizes, it will produce H plus and Cn minus. Cn minus is a polyatomic anion whose name is cyanide. Once again, because the name ends with an IDE, this acid falls under the "-ide" acid category. Okay, now in order to name the acid from the name of the anion, first step, attach a prefix hydro, replace the "-ide" with an "-ic", and a word, acid. So the name basically is hydrocyanic acid. Okay, go ahead and pause the recording while you work out the names of the following acids. Okay, welcome back. So the name of the second acid would be hydroethyl azic acid, hydrobromic acid, in one word, iodic acid. Okay, let's try out, go to the next category, the 8 acids. These are the acids which, when they ionize in water, will produce anions whose names end with an 8. One such example is H2SO4 as an example. Anyways, so the steps for naming such acids is, number 1, please note there is no hydro. Number 2, we take the stem of the name of the anion and attach the suffix ic and followed by a separate word acid. So taking an example, H2CO3, please note this is a molecular compound because there are no cations in it, and since H is the first listed element there, it is an acid. When this acid dissolves in water, it produces 2 H plus ions per molecule of the compound and an anion CO3 2 minus. This anion is called, what is this ion called? It's a polyatomic anion. If you remember, all anions that end with an 8 are polyatomic oxyanions. So this is a polyatomic anion that is called carbonate. Note the ending 8. And therefore, if you follow steps 1 and 2, the name of the acid is carbonic acid. Please note there is no hydro prefix in this category, and that is the difference between ide acids and 8 acids. Okay, let's try out a few such similar compounds. H2CrO4. Once again, let's start with the anion. The anion from this compound will be CrO4 2 minus, which, if you remember from your list of polyatomic anions, is called chromate. Since it's an 8 anion, this H2CrO4 is an 8 acid. So to name the acid, we replace the 8 with ic and attach the word acid. So the compound H2CrO4 is called chromic acid. Okay, please go ahead, pause the recording while you name the remaining acids following the steps given. So the next one would be perchloric acid. If you follow the steps given in the previous slide, the third one will be sulfic acid, and then phosphic acid, and then acetic acid. Now, I would like to mention something at this point for acids that have sulfur or phosphorus containing oxyacids. In other words, acids that will produce either sulfate or sulfite or phosphate or phosphite. Their names following the steps that were given in the previous slides are written in this slide. However, sulfic acid, nobody knows that word, or phosphoric acid, because for acids that are sulfur containing or phosphorus containing oxyacids, such as these two, there's a slight change, a modification that is made. In other words, for the sulfur ones, the UR of sulfur is retained, and the OR of phosphorus is retained. So instead of calling H2SO4 sulfic acid, we actually call it sulfuric acid. Instead of calling H3PO4 phosphoric acid, we call it phosphoric acid. Now this change, this modification is only applied to the sulfate, sulfide, or phosphate, phosphide producing acids. Okay, just as in previous cases, it was important to go from chemical formulas to names. It is in this case, and also from names to chemical formulas, we should be able to do that here as well. So if I gave you a name of an acid, oxalic acid, you should be able to work backwards and write the name. The chemical formula. So how do we do that? Hint number one. Note there is no hydro. If there is no hydro, the prefix hydro, that means it can't be an ide acid. Okay, that's hint number one. Hint number two is that the first word of the acid is ending with an ic. Since there is no hydro and the suffix is ic, it means that the anion making this acid or coming from this acid is oxalate. And now you have to remember the polyatomic ions that you were asked to memorize from your book. Oxalate is C2O4 2 minus. If that is the case, the chemical formula of oxalic acid will be H2C2O4. Okay, let's try out one more to give you a clearer idea. How about chloric acid? Once again, note that there is no hydro and the fact that the name of the first word ends with an ic. That means the anion is chlorate. Chlorate is ClO3 minus. So the chloric acid therefore will be HClO3. Okay. The third category of acids is the ite acids for naming purposes. These are the ones that make anions whose names end with an ite. And if you also remember from our previous sessions, whenever the name of an anion ends with an ite, that is also a polyatomic anion, though there are no exceptions there either. Okay, so let's look at the steps for naming these. Just as before in case of the 8 acids, notice that there is no hydro prefix. We replace the ite in the name of the anion with a suffix -us, OUS, and attach a separate word acid. For example, HClO2, this is an acid because it's a molecular compound and has an H as the first listed element. When this ionizes in water, will produce H plus and ClO2 minus. ClO2 minus is an anion called chlorite. Notice the ite in the name of the anion. So to name HClO2 that makes chlorite, we replace the ITE with OUS and the word acid. Please note once again that there is no hydro prefix in this case. Okay, let's try out a couple more. Here's another one. What will be the anion from this acid? So it will of course break up to make a proton and ClO minus. ClO minus is called hypochlorite. Again, it's an anion's name ending with an ITE, so HClO is called hypochlorous acid. Okay, go ahead and pause the video so that you can go ahead and try out naming these. Now please remember what we said in our previous slide. Sulfur and phosphorus containing oxyacids, their names are modified slightly by keeping the UR of sulfur and the OR of phosphorus. So that applies here as well. So this is called sulfurous acid, and this is called phosphorus acid.